Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, and this is our final episode of the Cooling and Resilience series, and I'm joined by the whole crew again. So g'day, Zack.
Hello, how are you?
Good. And Mary, how you doing?
Great. Nice to see you all again.
Yeah, and we've also got Ilka.
Yeah, hi.
And we're kind of joined on the show this week by a whole bunch of listeners who gave their thoughts on some hacks and DIY tips for keeping cool, which has been the theme of this series over the last few weeks. So we're going to get into listening to some of those. Really appreciate people giving the time to share their thoughts. Before we get into that, we've got someone to thank for this week's episode, Zack.
That's right. Big thank you to InnoTech Windows and Doors for being our sponsor of the week at Passive House Accelerator this week and making all of our programming possible. So big thank you to InnoTech. Also, thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority, and our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, StoCorp, and Zola Windows. And thanks to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050.
All right. Well, let's get into it. We had some responses from our SpecPipe application that we had on the website during the series, and some people called in and gave us their thoughts on houses. And to be honest, this made me somewhat comfortable in the knowledge that I'm not the only one that has a less than optimal house that needs some tweaking, particularly in the hotter months. So let's get into it. Who have we got first, Zack?
Yeah, so the first person is actually anonymous, but they do refer to SMUD, which gives us a hint about where they are, because what does SMUD stand for?
It's the Sacramento Municipal Utility District in Sacramento, California.
Excellent. So let's listen to their DIY hack.
So what I do is pretty simple and moderately effective, which is to run all the bathroom fans. I don't have a stove exhaust fan, or I would run that too, but just crack open the windows on the ground floor and run the fans all night long, and they will slowly act like a house overall house exhaust fan. They actually did a study at SMUD about 10 years ago that showed even like 100 CFM fan plugging away all night would do about as well over as long as the outside air is cool enough. Then close the windows, draw the shades, etc.
All right, so a bunch of strategies there, but the main one, running all the fans. I definitely run a whole house extractor fan during the summer. I try and keep it running, but I think that's a necessity in lots of parts. Any other thoughts on that one?
Only that it works when the air is not polluted outside.
Yeah.
Or hot and humid like it does get in Philadelphia in the summer.
Yeah, but I mean, I think that's the case with a lot of these DIY solutions. Is we're doing our best, right? So it's definitely resourceful. Great way to turn the air over.
All right, who we got next, Zack?
Next up, we have Paul Keeley.
Hi, this is Paul Keeley from EcoBuilt Passive House. We've been supplying pre-certified weather-tight shell envelope all across North America the past 8 years. We have a recent design, Mediterranean-style design inspired by a customer with lots of glass in a southwestern facing direction with zero shading. And we basically took a design that had a 50% higher cooling load than the passive standard, and we were able to get into a comfortable 15 to 20% below certification levels simply by playing with exterior window shading and window covering options from the Passive House window supplier. So just wanted to contribute that, looking at shading, window shading through the PHPP modeling.
I am a big fan of external shading, and it's something that I'm trying to encourage people to think more about. We've talked about it in this series, the fact that you often have to think about vertical shading and horizontal shading, particularly for the east and west windows, and then obviously looking at your whatever direction is facing the equator to minimize that. But that's a pretty impressive result, dropping that down to below the standard from a pretty heavily glazed elevation that's facing the equator, in your case, southerly aspect. Any other thoughts on that one, external shading?
Yeah, I think for me, over the, last so many years, I came to the conclusion, the exterior shading goes hand in hand with the solar heat gain coefficient of the windows, right? So it's not necessarily, you don't have to really keep the solar heat gain coefficient really down or minimal if you can control it, right? So when you do that with exterior shading. So for me, that's kind of the best of both worlds. But of course, convincing people to use exterior shading here in North America is not always the easiest.
Yep.
And I think we're going to hear more shading solutions coming up.
All right. Let's go to the next one.
Okay, next up is Frank Crawford.
Hello, my name is Frank Crawford. I'm a certified passive house designer and tradesperson calling from Calgary, Alberta, Canada. So my trick for keeping cool in the increasing summer heat, I applied to my uncertified passive house, and it consists of simply an exterior shade made up of landscaping shade fabric, which blocks about 80% of the incoming solar heat gain, and I made it into a screen and put it over my windows. Thank you. Bye.
Did he mention landscaping there?
Yeah, landscaping fabric, right?
Landscaping fabric, yeah. Oh, yeah. Landscaping fabric, right. So not necessarily vegetation, but a fabric shade.
Right, the fabric. Yeah, exactly.
Because I think someone else, we have touched on the use of vegetation during this series. People have talked about the effectiveness of that. And I've actually witnessed that somebody's shown me a model just this week and identified an end unit, which anyone would have looked at this plan and expected it to be the worst of a row of houses because it was the one that was getting the most sun. But then they said, oh, no, there's a really big tree. And when we account for that in the energy model, that unit is actually not the most likely to overheat, which points to that influence of shading from not just trees, but other buildings, which can kind of be a bit complicated in the model, but definitely worthwhile. I don't know if you've played around with that in your modeling, Ilka, with looking at other buildings and other shading features.
Yeah, definitely. That's always part of like going through a certification process, is really looking at what's around the buildings and what shades each window, basically. So that's definitely crucial. And then also to acknowledge if the tree is, shading the window all year around or just in the summer.
Right,
so,
deciduous versus evergreen.
Yeah. So that's definitely important to look at.
Also, just as we look at future years and how the climate might change, it's important to think about how the trees grow, right? I mean, if you're going to be in the building for a while, I myself have been in my house for 30 years, and it's really different because the trees are shading me much more than they were when I first moved in.
Very good. All right. Who we got next, Zack?
Yeah, yay for the trees. We have Foti Bululargus.
Hello, my name is Foti from Montreal, Canada. So I did a retrofit on a 3-story brownstone in Montreal, Canada. The ground floor was retrofitted completely, fully insulated on the inside, crawl space, new windows, new doors, carefully insulated with cork and wood fiber insulation, also with air barriers and liquid applied, all that stuff that we always speak about. The cooling solution is passive at the moment. We're trying to limit the energy usage and reliance on electricity. So at the moment it's passive, but the house is fully monitored with sensors in the walls, outside, inside, in crawl spaces. So I'm gathering at least a year's data. I'm at about 8 months of data now, and the cooling seems adequate. Could be better, but we'll have some better data once a full year has passed.
The ultimate MacGyver. Retrofit to passive house. That's awesome.
Yeah. And I was pleased to hear this one because it mentioned monitoring, and that's something that I'm a big fan of. Bit of a nerd when it comes to actually gathering data about what's going on. Something that we're looking at here is also gathering multiple data points within a single room, because that can tell us a lot about the comfort as well. It's often not enough just to have one temperature sensor in the middle of the ceiling. And the ability with sensors these days to pick up more data points across the room to see if there's any stratification or big temperature gradients, because that can heavily impact comfort, but also gives a much bigger, a better picture of what's going on. So I always like hearing, of course, passive house, the data monitoring tends to be really, really boring. Which is kind of what you want. If it's showing flatline temperature in the room, then that's a good thing. The more interesting posts on LinkedIn tend to be from really bad performing houses, where you get these really high peaks and low troughs of temperature. And how have we got next, Zack?
We have Rob Hoskin.
Here are some MacGyver tips for Tad Everard with his one-window air conditioner. Since he has an extract air vent in the bedroom where the air conditioner is installed, you could do a few things. First, yes, definitely run the air conditioner 24 hours a day to help cool the whole house. Second, consider using an auxiliary freestanding fan to blow the cool air out of the room. And last but not least, do a home energy radar trick and put a piece of duct seal tape over your extract air so it doesn't suck your cool air out of the room.
Awesome. And that was a response that Rob was making to episode 199, where Tad Everhart shared the results of his interfit retrofit and what they've been experiencing. So that was great.
Yeah, always interested in people taping up vents. I think you probably want to be a little bit careful and make sure you know what you're doing. If you're hacking things or DIYing things to that extent, it can work in certain situations. But make sure you know what you're taping up and what you're not. We have talked in other episodes about making use of cool air or getting rid of hot air that's coming from one place or the other, particularly when you have a heat pump that's working and moving heat from one place to the other. Interesting stuff.
Matthew, I just wanted to ask you, definitely you got to be careful about creating imbalances in pressure in the building by taping up a vent. But if you're doing it for a heat wave just for 3 days, that's not really going to create a problem, would it?
No, I think that's a good point. And often we are talking about extremes. And in fact, that came up in the interview last week, which I think we'll get onto about. And I think this comes across, we've talked about in the past, Zack, when you've had really high rates of pollutants in the air and really low air quality. these are kind of drastic situations, which, you just have to do what you need to do for that period of the heat dome or whatever the current situation is.
Yeah, exactly. Like in our situation with our house, if we're in a heat wave and there's horrible wildfire smoke outside, we're closing everything up. We're running our Corsi Rosenthal cube to clean any smoke that does get into the house, and we're hanging out in our finished basement and dealing with high CO2 levels for the duration. But it's just like the lesser of the evils because we don't want to be exposed to the toxic smoke. So yeah, right. It's triage time.
Yeah.
So I also thought it was interesting about this comment, and going back to Tad's interview, the whole issue of moving air around. And it seems to be a little harder in a passive house than people would have expected, right? I think what Tad was saying, that he expected this like cool air cascading down the stair, and it just didn't happen. So just, trying to just move the air to places where it needs to be seems to be very crucial.
Yeah, because there are no drafts because it's by design,
right, not
drafty.
Well, I thought it was interesting going back to that episode 199 of just that insight that it's easier to distribute the heating than it is the cooling because of the delta T, right, and the temperature of the air. So yeah, in these moments, using maybe a box fan to distribute that cooling from that one room could be a good approach.
Kind of related to that, in last week's episode, I think it was, there was an example about the kids coming home and turning on a bunch of devices and an increase in internal gains. And I think that's another area that is particularly relevant to passive houses because the envelope is so good. Any change in internal gains can make a big difference because you're very close to this balance because it's been designed that way. So and I've had similar experience I've heard of when people move into their passive house and it's great, it's been optimized for their family, and then they have a housewarming party and suddenly there are 20 people in the house and it gets really, really hot because all of that heat, which would just escape from a regular house, is getting retained so well from a passive house because of the air tightness and the high levels of insulation. So that needs to be dealt with. And one of my colleagues is she did her PhD on just this issue of how impactful internal gains are when the building envelope is so good. And that's one of the, I think particularly in passive house world that not just designers but occupants of passive houses need to be very conscious of, because things that you wouldn't necessarily think of before, like just a big TV or having lots of appliances, can all start stacking up. There's just small amounts of heat individually, but it all adds up. And if it's not escaping, then it's just going to add on top of each other.
Yeah, and also hot water pipes. I actually just did an energy model this week where I couldn't figure out why my internal or why it was overheating, because there wasn't much glazing, especially not to the south. And I really couldn't figure out why this was happening until I found this little mistake that I made in the length of the hot water pipes.
Right.
And all of a sudden, once I figured out, okay, I set it to 6 hours instead of to 0, and the length was not right. All of a sudden, it all worked out. So, but these little, you kind of underestimate even where your hot water heater is and how long the pipes have to, or the water has to travel through the pipes. That plays a big role too in terms of overheating.
Right. And going back to what you were saying, Matthew, about parties, for people who have summer birthdays, make sure you can have your party outside.
Yeah.
Not just the cooking, as Tad suggested. We cook everything outdoors, but also okay, you're not allowed to come in, just one person at a time.
Yeah, and if you do, don't breathe.
One of my first, I organized a tour of Seattle architects to Dan Whitmore's house, one of the first passive house projects built in Seattle, one summer. And there was a bunch of construction happening next door, so we had to keep the doors closed. And so we had this group of a whole bunch of architects come into Dan's house. And we hadn't thought of trying to like pre-cool it or anything. And so they all come in and we have to close it. We can't, and nobody can hear and it was just the most backfiery tour of a passive house possible. It's like, they're actually really comfortable. It's just that, it's like,
there's too many of you.
Yeah. It was definitely, you say you got to experience to really understand, and not in that situation.
Yeah. Okay. All right. Who we got next here, Zach?
Well, we are going back to the 3 experts that were that Ilka interviewed last week for episode 201. So we'll hear first from Prudence Ferreira, her DIY solution.
So I have an 1899 Victorian in Mid-Coast, Maine that I retrofitted, but not to passive house standards. Couldn't get appraised for the money that I wanted and needed to do that, but I've got heat pumps in there. And it gets mighty humid here in the summer, increasingly so. And so I've only got 2 heat pumps and about 2 heat pump heads in about 1,100 square feet, one in the bedroom and one kind of in my dining room space. It's a long sort of, railroad style layout. I turn the heat pump on. I angle the slats of the fan downwards to where I have a floor fan. And then I have that floor fan just blow that air right down the hall. And then the same thing in the bedroom. I'll put a fan in the bedroom and have it sort of blow out into the rest of the house. And then I put the shades down on the windows that are getting solar gain during the day, and I do not open them until it gets dark out. And that keeps things pretty cool.
Cool. So that's similar to Rob Hoskins' advice to Tad Everhart.
Yeah. So
the fan. Yeah.
Prudence is in Maine, is she?
Yep.
And so she mentioned it gets quite humid there, which is an issue as well as heat, which we've also covered during the series as being a really big component of comfort. And just that recognition again that you're going to have to use some mechanical cooling.
All right. So next up is Ryan Abendroth.
But I will say there becomes a point where, you try all these things to save maybe a little bit of money in cooling energy or something, but it becomes like $3 a month, and so whether it was worth it, right, to have like a fan with a ice, or water spritzer on it is a whole nother question. But the thing that I do is I have a large patio door. And I usually keep my umbrella up out on the patio to just cut the solar gain. It's operable exterior shading, like we were discussing earlier. I just have to go out and crank up and down the umbrella on the very sunny, hot days.
That's pretty similar to your solution, Mary, right? Or one of your solutions.
I mean, except mine's even more DIY in that I just take old sheets and put them on the clothesline outside my bigger windows that are east facing and shade the windows that way. It's not 100% effective, but it really helps.
Okay, so next up we have Christina Schneider.
So I already told you a little of what I'm doing at my house. We will be adding a heat pump to be able to handle the dehumidification, but we ventilate on the coldest nights in the summertime, and since we're zone 5, sometimes that's down in the 50 to 60 degree range, and the passive house can trap those temperatures for several days. We try to keep heat and humidity out in the summertime, so we do move a lot of our cooking tasks outside and dry clothes outside. I think one of my pet peeves that I see a lot of advertisements for what they call personal air conditioning or portable air conditioning, but they're really just evaporative coolers, basically a fan with some sort of water source that's adding humidity to the space, but the air feels cooler when it's blowing on you. Those can actually be deadly in a hot, humid climate. They're great for an arid climate where you can trust that the humidity is going to get out of the building. But in a hot and humid climate, you add too much humidity to the air, and at some point your sweat will no longer be able to evaporate when you get to like 100% saturated humidity. And then there's no way to cool down your body temperature other than getting yourself immersed in cooler temperatures. So I prefer to eat frozen fruit to try to reduce my core temperature if I get overheated. When I come in, I eat something cold. I lay down on a section of concrete floor that's ground coupled, and that sucks the heat out of my body immediately. That's how I cool down if it's crucial. The basement is about 10 degrees cooler than the loft in my house, and so I will spend time in the coldest room in the house if I need to without cooling. But in an arid climate, you've got a lot more options. You can use evaporative coolers and not have to have AC to get comfort. You can make ice in the desert without refrigeration equipment because you can use radiant cooling to the night sky. And you can basically take like a solar hot water system, point it at the night sky. You need to keep it covered up during the daytime, but you can have like heat exchangers inside the house, hydronic heat exchangers, taking heat from the building all night and exposing it to the sky through the solar array that's really a radiant cooling array. So those kinds of systems can work in the desert, but they don't work in a hot, humid climate where you've got too much cloud cover.
So some potentially complex options there, but the simple one of just using parts of your house or knowing where they're cooler. I think Zack, you mentioned that you often retreat to the basement when it gets really hot.
Yeah, that's right. Or and eating frozen fruit. I mean, those are all so resourceful. And as I listen to it, I'm like, oh boy, this is the climate change is. We're just going to need to know these things, you know, like how to. Yeah, it's kind of it's sobering. Sure.
I think the interesting thing about that she talked about lowering your body temperature as well, and that we are sort of getting into, I think, areas of beyond just comfort, but actually. Okay, I'm actually overheating now. I need to do something about it. And a lot of people have swimming pools here or temporary swimming pools, and that can be that can have quite an impact. Just dumping in the water and cooling down, and that can kind of last for a while just to cool the body temperature down. It's not doesn't seem like a long-term sustainable solution for comfort inside the home, but these are sort of things that people are having to start to think about and deal with.
Yeah. Ministry of the Future. I don't know if any of you have read that, but there's that just brings up a very powerful scene in that book where people are retreating to the lake and the water isn't actually cool enough for people. It's intense. Really important cautionary tale there about the evaporative cooling and a reminder that it doesn't work everywhere. For sure. Yeah. And I think even there are other issues I know of. Anytime you have water in a warm environment, you also have to be careful of like Legionellas and things like that. I have heard of
things like that happening, because evaporative cooling we talked about this, I think a couple of episodes ago, Zack, with Andy, that have been quite common in Australia, in parts of Australia that are very dry heat, which they can be effective in those areas. But I think there's more of a tendency now to move towards reverse cycle split system air conditioning, just because of its effectiveness. And you also get a dehumidifier with those systems, so they work more in the tropical environments as well.
Mm-hmm. And also I remember in that episode just the observation that how water intensive that those evaporative cooling systems are, right? When they're like on the roof.
Yeah, and of course that's the other issue in somewhere like Adelaide in South Australia or Perth in Western Australia. There's not a lot of water, so some households will pay as much for water as they do for electricity. So they're very conscious of just evaporating that into the air and having to pay for all that water as well.
Yeah. Also, physics. Sorry, Ilka. Go ahead.
No, I was just going to say how all these comments show again how climate specific all these solutions are too. Because I was going to say for us here in Philadelphia, when it gets really hot and humid, especially at night, there's no like night flushing or night cooling. Yeah. And it's more about just turning the AC on. We have window units, not in every room. So our house shrinks drastically in the summer because we retreat into the rooms that have these window units. But it's almost just about drying the air rather than like making it really cool in the room. Just making the air less humid is just a big relief at night.
Yeah.
Physics is so cool. Creating ice in the desert at night.
Yeah.
That's kind of. I mean, I know I've heard that before, but it just it was kind of blows your mind. But I think another thing that this points out, speaking of physics and building physics and passive house, is that these DIY solutions are important and good for all of us to know about it. And we're obviously all using them, those of us who aren't yet in passive houses, and making our buildings more resilient to these events and to the heat is super important. Another thought that I remember Daniel Kress from Australia really emphasizing this in a presentation he made at Passive House Accelerator, is that the good news is that active cooling coincides with lots of solar energy. So if we can make our buildings, thermally resistant and airtight, so that our heat pumps don't need to be very large, and so we don't have a whole bunch of refrigerant in them, the environmental, that reduces the environmental impact of active cooling, and is another kind of form of resilience, especially if we can have battery backup and those kinds of things.
Yeah. So. Yeah. Well, I know in South Australia, there have been days during recent summers where they've been a net exporter of power because of the prevalence now of solar panels. There's some quite large solar farms there. So there's definitely ways of creating an abundance of electricity. You mentioned refrigerants. There are some exciting developments around moving away from some very harmful refrigerants, because the other issue is not just the power consumption, but the leakage of some of the refrigerants, which are astronomically high in terms of their global warming impact. Very, very they're just not things that we want to have escaping from air conditioners. So moving towards things, ironically, like CO2, which is a much better or much lower greenhouse gas than some of the other more traditional refrigerants, which are orders of magnitude worse than CO2 if they get into the atmosphere. So that's an exciting development so that we can kind of use more air conditioning that's ideally powered from a renewable source, and also doesn't have as much of an impact when it leaks, because it's a question of when it leaks, not so much if. These systems are known to leak over their lifetime, So yeah, we just have to assume there's always going to be some leakage of those refrigerant gases into the atmosphere. Wow, there's a lot there, a lot that we've covered. Any sort of final comments, thoughts, or our own tips that people have got that we haven't talked about already?
I would just mention that the Corsi Rosenthal box, and I just realized that I misspoke when I said it was episode 199 that Tad Everhart was featured in. It was actually episode 198. And I know that because episode 199 was with John Semmeltack, and we really focused on the Corsi Rosenthal DIY air scrubber box thing. And I have one of those, and it's been very helpful for the wildfire smoke. But also, just more recently, our second child came down with COVID. He's now COVID negative, but he was COVID positive for a full week, and we had that box running full blast in the common area that he was hanging out in. And so far, so good. Knock on wood. None of us came down with COVID, so it has multiple purposes.
It scrubbed the viruses as well.
Hopefully so. Hopefully so.
Yeah. One thing I'd like to just, I don't know if we talked about a lot, which is fly screens or insect screens. I know this is quite big in Australia to talk about protection from embers, but they go a long way to the ability or people's feeling of being able to open windows freely, because insects are up there with noise and other pollutants as reasons that some people may want to keep things closed. And for just the whatever the local market is, I know that they have more prevalence in some places than others, but there are nearly every house in Australia, southern parts of Australia, will have some form of a fly screen or a double door, so that you can have air movement while trying to keep the bugs and the flies out. I know a lot of people go to quite an expense to retrofit that to houses to allow for better ventilation here, but it's definitely something that is beneficial. I've probably got way more, having grown up in Adelaide, which is hot. There are probably things that I took for granted growing up that were kind of strategies to try and keep cool in the summer. I think there's a lot that we have covered in this series. I guess a couple of outtakes, main points for me, just to summarize. One is that things are getting warmer. We've heard multiple instances of people being okay previously, but are now having to adopt strategies or install equipment to cope because the temperatures have changed, and they are going to change. So we also hear about people using future climate files instead of relying on current, which are kind of based on historical data. And here I'm on a bit of a campaign for just ventilation in general at the moment. And I think, outside of the passive house realm, people just don't appreciate the value of the air moving, whether it's bringing fresh air into a home or moving air around with ceiling fans or ducting or whatever it is, but just the value of ventilation. I don't know if anyone else has got any sort of overarching themes that have come out of this series.
Well, since we're campaigning, I would campaign for exterior shading removal or movable exterior shading. And since I didn't grow up in the States either, I grew up in Germany, where these roller shutters is basically on almost every house, where you can really control all your solar gains. So you can control, even keeping the heat in. So they're very effective in so many ways. And I think it would be nice if there were products, if there was more product availability here in the States too, that people can actually use and afford.
If people, I want to do a quick shout out for Lloyd Alter's Substack. He's just put out a article this week on the use of awnings for beating the heat, and he references traditional use of external shading and awnings and how it's kind of may be coming back into vogue again, or needs to come back into vogue, as you say, Ilka. So he's quite prolific these days. Definitely worth following. If you don't follow him already, check out Lloyd Alter on Substack. And he's done some recent articles about shading and keeping cool as well. All right, any other sort of closing thoughts, comments about our series?
I think it might have been you, Matthew, who was talking about that with rising temperatures, the water is rising, the sea temperature. So, for people who are lucky enough to live near the ocean, you can't even count on that anymore. The temperature I was just reading in the Mediterranean is 86 degrees. Yeah. I mean, that's not very cooling if you're trying to, so.
Well, not only that, it's contributing to the higher humidity as well. So it's increasing the discomfort, even if you're not able to cool down in the water, like jumping in and go for a swim. It's making the areas more humid. Yeah. Awesome. All right. Well, I think that just about wraps it up for us. I think this has been a really important and informative series. I've really enjoyed. Thank you all for the interviews that you've contributed to this. I think we're going to be talking more and more about all of these topics because it is something that is increasing all over the place. People are becoming aware of it and also looking for strategy. So there's lots of opportunities there. And also some things that we can look back on the way things were done or have been done in the past and bring those into sort of more modern designs. So thank you all. We got anything to plug coming up, Zack?
Indeed. Next week we start at Passive House Accelerator Live Wednesdays again. So please join us on September 4th at noon Eastern for the kickoff, where we'll be looking at the power of community and learning and some exciting announcements about what's coming up this fall with us at the Accelerator and the broader Passive House community. And also another shout out to InnoTech Windows and Doors for being our sponsor of the week this week.
Great. Hey, well, thank you all. Thanks very much for listening in, and we'll be back again next week on Passive House Podcast.